Hello, today we are looking at 13.2, our second day where our focus is going to be on radians. We're going to do a quick review from yesterday's video when we're going to look at conversion. So if I want to go from radians to degrees, that means I want to get rid of my pi. If I want to get rid of my pi, that means I'm going to multiply by 180 over pi. If I want to go from degrees to radians, that means I want to keep the pi, I want to get the pi, so I want the pi to be on top by pi over 180. Alright, so to do our conversions, we have degrees. We know it's degrees because of our degree symbol. That means that we have to get the pi, so I multiply by pi over 180. The 180s cancel, leaving me with just pi. Now we did do this yesterday, so I want you to try the next four on your own. Okay, let's see how you did. Our second one, which we did not do together, the first one you have to do on your own, we have radians, so we want to get rid of the pi, so we multiply by 180 over pi. Your pi's canceled, then you reduce 180 over 4, which comes to, don't forget your negative 45 degrees. We know that we have radians because we have the pi symbol. We want to get rid of the pi, so we divide by pi, so it's 180 over pi. So we've got 13 times 180 divided by 9 gives us 260 degrees. We have degrees to radians, so we multiply by pi over 180, giving us 35 pi over 9. You are reducing that 700 over 180. And last, we have radians to degrees, so we want to get rid of that pi. Those pi's cancel. Negative 25 times 180 divided by 3 leaves you with a negative 1500 degrees. Alright, we are going to touch base with the unit circle. We're going to go much deeper into the unit circle in just a couple days. But the unit circle is, you see that our normal axes that we've been dealing with, we have a circle around it. What we're going to do is we're going to call it a unit circle, because if you ever think about something called a unit price, it's the price per one. So in the unit circle, we are assuming a radius of 1 unit. So we're going to go ahead and start with degrees from yesterday. We know that this is 0 degrees. We have 90 degrees. We have 180 degrees. 270 degrees, and all the way around is 360 degrees. Let's go ahead and add some more detail to that. Let's say that we go halfway between 0 and 90 is 45 degrees. Halfway between 90 and 180, we just add another 45 there, is 135 degrees. And halfway between 180 and 270, 45 degrees past 180 is 225 degrees. Halfway between 270 and 360, add another 45 to 270 gives us 315 degrees. We're not done though. When we learned about last year, we had special rights. We reviewed special rights again this year. So we talked about 45, 45, 90 triangles. We also talked about 30, 60, 90 triangles. So if from 0 to 90, 30 and 60 are going to be a third. So if I go about a third of the way, there's 30 degrees. If I go another third, there's 60. Let's go ahead, let's do this in a different color. So I've got 30, 60, 90. I'm going to cut this into thirds as well. So 90 plus 30 gives us 120. 120 plus 30 gives us 150. Plus 30, we're at 180. Plus 30, we've got 210. Plus 30, we've got 240. Oops. Plus 30, we're at 270. Plus 30, we're at 300. Plus 30, we're at 330. Now what I want you to do is I want you to take all of these degree measures which you are familiar with on a circle, and I want you to convert them all to radians. And if you remember from yesterday, 0 is still going to be 0. We said that 360 degrees was equal to 2 pi. So this might take you a minute or two, And I want you to actually do this. I don't want you just to cheat and keep it going and then copy down my answers. I want you to press pause and take each of these and convert them. So take 30 degrees, convert it to radians. 45 degrees, convert to radians, and so forth. So go ahead and press pause. Okay, the first thing that I want you to do is to go ahead and check all of your answers. Make sure that all of your conversions match up with mine. So if you need to, which you probably do, go ahead and press pause and check your answers and make any necessary corrections. Pretty much the entire rest of the chapter is going to be based upon this unit circle. So if you have wrong information now, it's going to set you up for failure in the end. What we want to look at are the patterns that we see. As we look around, I kind of color coded it so maybe your patterns are becoming a little bit more obvious, but we know that the entire circle is from 0 to 2 pi. So it makes sense that if I'm from 0, if I go halfway around my circle, half of 2 pi is just 1 pi, just like half of 360 is 180. Well, if I go halfway in between there, I'm only going a quarter the way. So a quarter of 2 pi is pi over 2, or halfway between 1 and 2, or 0 and 1 is 1/2. So each time I go 90 degrees, I'm increasing by how many radians? By half of a radian. So 0 plus 1/2 is 1/2 pi, plus 1/2 is 1, plus 1/2 is, plus 1/2 is 3/2 pi. 3/2, which is 1/2 plus 1 more half, gives us 2 pi. So each 90 degree mark, we are adding 1/2. Now if you look in purple, I'm halfway. So halfway between 0 and 1/2 is 1/4. So this is 1/4 pi. 1/4 plus 1/4 is 1/2. 1/2 plus 1/4 is 3/4. 3/4 plus 1/4 is 4 over 4, which is just 1, plus 1/4 gives us 5/4. 5/4 plus 1, that would be 6/4, which would reduce down to 3/2, plus 1/4, which would be 7/4. 7/4 plus 1/4 would be 8/4, which is just 2. So each halfway mark, I'm adding a quarter. Then we look at our 30 and our 60. We're increasing by thirds. So if I take 1/2 and I cut that into thirds, I'm going by 1/6. So 1/6 plus 1/6 is 2/6, which reduces down to 1/3. Plus 1/6 is 1/2. Plus 1/6 is 2/3. And if you notice, each time I'm adding 1/6. Notice that these axes are a part of both patterns. 30, 60s, each time we increase, the reds for degrees and the green for radians follow one pattern. The purple and the blue, the halfway marks, follow a completely separate pattern, but all four corners of our axes are related to both of them. So these are part of the 30-degree increments and the 45-degree increments. But again, there are those patterns. For the 30s, for the green, we're going up by 1/6 each time, because 30 is 1/6 of the whole thing. And it's all breaking down in these proportions, following the whole pattern around the entire circle. It is very, very important that you get that pattern down, because it's going to make life much, much easier. Alright, so let's go ahead and turn on over to the back page. Yesterday we graphed an angle that was in standard form of degrees. Today we're going to graph the standard form of those that are in radians. So instead of 90 here, we have pi over 2. Instead of 180, we have pi. Instead of 270, we have 3 pi over 2. And instead of 2 pi, instead of 360, we have 2 pi. So if I look at 7 pi over 9, I can reference my last page. I want to know, where is 7/9 located? And I know fractions are not our friends, and lots of us don't like fractions and you don't see it. We'll take 7/9 in your calculator, divide it, and find the decimal, and see which one of these it's closest to. And when we graph, it is a positive angle measure, so we're going to go in the positive direction, and we're going to end up about right here. Our vertex always coming from the origin. Now that is how you graph an angle measure in standard form given radians. It is helpful to know, it is very useful, it does make a difference. However, I do think that there is a shortcut, not a shortcut, it's actually more work, but easier for some of you. What some of you are going to end up doing every single time, and it's okay, is take those radians and convert them. Convert it to degrees. And when I convert it into degrees, that handy tool that we've done the last 2 days, we end up with 140 degrees. Most of you feel more comfortable in degrees than in radians because that's what you're used to. That's what you've always graphed in. And then we can see easily that 140 is between 90 and 80, and it's close to 1/2. So probably my graph probably wasn't necessarily the best. It probably should be just slightly more over here. But again, it's not 100% accurate or 100% perfect. It has to be accurate. So you have the option, like I can look at negative pi over 2. Pi over 2 is 90 degrees. So I know right away that that's a negative 90 degrees. I start at 0. Instead of going positive 90, I have to go negative 90. So I'm going from here to here, with that being my angle measure. And you want to make sure that I know it's hard to see sometimes, that you draw your angle enough that I can see where it's ending up at. So it is 100% your choice. You can keep it in radians, but if you want to take one extra step, it's a little bit more work, you can go ahead and convert it into degrees, reduce your fraction, and you get a negative 560 degrees. Even though it's more work, it does sometimes, it's easier for some of you. So if I want to graph a negative 560, we start at 0 like always. If I go once around in the negative direction, that's negative 360. So let's go ahead and label negative 90, negative 180, negative 270, negative 360. We got to keep on going. A negative 90 more would be a negative 450. Another 90 would be negative 540. And then another negative 90 would be a negative 630. And now we can see that our negative 560 degree is going to be slightly past here and probably ending up right about there. Okay, so I want you to make the choice whether you want to look back at the previous page and graph in radians or convert to degrees. Remember, converting to degrees is actually more work than just graphing in radians, but you might feel more comfortable with it. It's your choice. Go ahead and press pause and try graphing the next 3 in standard form. All right, let's see how you did. I did convert it to degrees so that it would be easier for you to see. If we're at a negative 160, we start at 0, negative 90, negative 180. We are going to be closer to the negative 180 than to the negative 90. Remember, those 30 degree, 45 degree increments are what you're going to base your decisions on where to put your arrows about. When we convert here, we get 1080 degrees. So we start at 0, then 90, 180, 270, 360. We got to keep on going. 450, 510, 630, 720, 810, 900, 990, 180. And we actually end up exactly on that axis, and it took us 3 times to get around it. A quick way to understand how many times you're going to have to go around, well, we know that each revolution, each rotation around is going to be 360 degrees, and when I divide that, I get exactly 3. If I get 3 in a decimal, that means I'm going to go 3 plus more, but not to a 4th revolution. If I get 5 point something, again, I have to go more than 5 times around. So it'll tell you how many times that you should expect to have to go around your circle. Then we get a negative 35. We know it's going to be closer to our 0 than to the negative 90. And again, think about the 30, 45, 60 degree mark as you are placing that arrow, where about would negative 35 go? You don't want it to go halfway because we know halfway is a negative 45. Okay, almost done. Finding those positive and negative coterminal angles. So instead of adding, subtracting 360 as we did yesterday, that's when we're in degree mode. When we're in degree mode, each circle is 360 degrees. So when I add a rotation or subtract a rotation, I'm adding that 360. When I want to add, subtract for radians, one whole circle is 2 pi for your radians. So when I want positive, negative, I'm going to add 2 pi. So 2 pi 3 divided by 3. If I want a positive coterminal angle, I add 2 pi. And remember, just do the 2/3 plus the 2 in your calculator. Don't put the pi in because we want exact answers. We get 8 pi over 3. That's not always the only one. Remember, it's infinite. I can keep on adding 2 pi. I just keep on going around my circle, around and around and around. If I want a negative coterminal, I subtract 2 pi. And 2/3 minus 2 gives me a negative 4 pi over 3. Here we've got a negative 77 pi over 18. If I want a positive, we add 2 pi. When I add 2 pi, unfortunately, I was going for a positive coterminal angle, but I ended up with a negative 1. And if I take that negative 41 pi over 18 and I add 2 pi again, do you think I'm going to get a positive or a negative? I still get a negative pi over 18. So either one of those would be acceptable negative coterminal angles. Remember, there's no one right or wrong. It's just, is it a multiple? Is it one rotation around the circle? So we got to keep on going. So we take our negative 5 pi over 18 and we add 2 more pi. And when we add 2 more pi, we finally end up with a positive answer of 31 pi over 18. Now let's say you try to do the negative coterminal first. We have a negative 77 pi over 18 and we subtracted 2 pi. That's okay too, because sometimes you do the negative first. And when we subtract our 2 there, we end up getting a negative 113 pi over 18. That would have also been an acceptable answer for your negative coterminal, just as long as one is positive and one is negative. When you get to these cases where it is positive and negative, or you got to keep on adding or keep on subtracting, what you want to ask yourself is, how many times do I have to go around the circle to make it either positive or negative, depending on which one you want to go? And to do that, just divide by your pi. Find out how many rotations it is. And then instead of adding 2 pi, we could have taken that and added multiples of 2 pi. So if I would have added 3 rotations around, I would have ended up at the same place as I did by keep on adding. So I had to add that 2 pi 3 times. It's completely up to you on how you want to do it. So go ahead and press pause, do the last one on your own. Okay, so I found my coterminal positive first by adding 2 pi, and I got 38 pi over 9. But I could have also recognized the fact that if I were to subtract a rotation, if I would go in the other direction, I would still end up positive. So either one of these would be the most likely answers that you would get on a quiz or test. I keep on subtracting until I get a negative coterminal angle. Okay, and we are all done for today.